Okay, so this has no guarantees of being right because I did not check it with a TA because look, there's no one here. Anyways, so we have x. So this is in terms of x. This is one of those questions, right? So x equals y squared. We know what that looks like. And then x equals 2 minus y squared. So the thing about x equals 2 minus y squared is that, at least for me, I kept thinking that it meant that we shifted the x to the right or left or whatever, right? To the left, actually, right? Based on just like how like negatives work. That's what we assumed. But when we put it in terms of x, we essentially just get this. So which means it shifts to the right too. So here we could see that we have our x is equal to y squared here, which is just looks like that. And then our shift to this way, shift 2, and now it's like that. This is our shaded area now. But now it says about x equals 4. So our x equals 4 is here. I think we have a big line here, right? And then over there, we actually do the same thing on that side, and now we have two different areas, right? So now that we have two different areas, we can determine our little r and big R, which we need for our area equation. But here's the thing. So here in our equation, it says 2 pi. Why does it say that? So here it says that we have two. So because of the fact that we have it reflected over x equals 4, we have two different areas to highlight, but they're the same, like the area is the exact same. So we just put the 2 over here. And now we plug in our integral. So we know that it goes from 0 to 1. And we have 4 minus 2 minus y squared based on our big R. Because in the case of our big R, which is like the long area, right? We're basically taking this and adding the 2 that we left behind. Well, minusing the 2 we left behind. So now it's 4 minus 2 minus y squared minus 4 minus y squared, which should be our little r. And then don't forget to add dy, very important. And then we basically just FOIL it all out. Keep foiling until we get here. And then we integrate. Don't forget dy. And then we integrate. So 2 pi, and then we have our integration. And now we don't need dy anymore because we have our integration. And just put this bracket, 1, 0. And then now we can actually properly plug in. We already know that plugging in 0 here would just get us 0. So we can just worry about 1. So 2 pi times 4 over 3 minus 12. Right? And what we did here from now is we actually minus this inside first just for convenience. So 4 over 3 minus 12 is also equal to 4 over 3 4 over 3 minus 36 over 3. And now that we have, and then when we minus that, we have negative 32 over 3. And now we can multiply that by 2 pi, which gets us negative 64 pi over 3. And that should be our answer.